Remember, as we try these dimensional analysis problems, that the goal is not necessarily the answer. Converting within the metric system is a middle school standard. I'm not teaching you how to convert within the metric system. If you learn that in the process, it's just a bonus. What I'm teaching you right now is the process of dimensional analysis, because this is going to help us later once we get into high school standards. So one of the first things we talk about is the point of dimensional analysis. Remember, we're trying to change the dimensions of what we're talking about. If I'm looking at this 2-liter bottle on the side here, and we're talking about converting the liters into milliliters, the volume in my bottle is not going to change. The measured amount of liquid in my bottle is not going to change. Just the unit changes from liters to milliliters. So when you try these problems, I really want you to focus on the process. If you can solve this a different way, that's awesome. Let's start there and build upon it. Start with your knowledge and then see if you can fit it into the process of dimensional analysis. So pause the video here and try as many of these as you can. Okay, so as we look at this first one, I'm always going to try to set this up in the format of a measured value times a conversion factor equals an answer. Okay, so this is the format in which we're trying to put things. So the first thing we're going to look at is what's the measured number that I have about this bottle and what is the answer that I want. So as I read this, I see that it's a 1.5 liter bottle and we're looking for how much he drank in milliliters. So my measured number is going to be that thing that's true about this bottle, whereas if I grab a different bottle off the shelf on Winco, that amount might change. That's how I know it's my measured number. So 1.5 liters, and then I want my answer in milliliters. So I'm going to set it up like this. Which means we need to figure out our conversion factor. So when I'm looking at our conversion factor, remember, whatever is on top here, I'm going to automatically put on the bottom here. Liters over liters will reduce out, so I'll get to cross them out. Whatever I have over here in milliliters, I'm going to want on top in milliliters also. So I know my conversion factor is going to be milliliters and liters, and now it's a fraction. There's 2 units, and the top in milliliters needs to be equal to the bottom in liters. So we need to think about what that is. How many milliliters is equal to how many liters? And it's 1,000 milliliters is equal to 1 liter. So I can go ahead and plug that in. 1,000 milliliters is equal to 1 liter. Now I just plug information into my calculator and I take a look at my units. Do I have liters on top and the bottom? Yes, I do. So milliliters is going to be the only unit that's left, and that's what I want to be left over in the end. And then I do 1.5 times 1,000 divided by 1, and I get 1,500. That is our answer, and we set it up using dimensional analysis. So now revisit to again and see if you can set that one up in dimensional analysis also. You're going to use this answer from number 1 to start number 2. If you get through this, try 3 and 4, and then I'll put solutions up for those in just a moment. Okay, if you tried the other problems, here are the solutions. Now, I don't expect you to be pros at this. We're going to try this over and over and over again until you're comfortable with this. But I hope what you see from these problems is you don't have to understand the concepts as long as you can line up 1 unit on top and 1 unit on bottom. That's the same for number 3 here, which looks really complicated, but all I did was I took the thing that I wanted. I know I want joules in the end. I took my conversion factor in the middle here, and I just lined up grams on top to get rid of grams on the bottom. I lined up degrees Celsius on top to get rid of degrees Celsius on the bottom. As long as you can line up units so that they reduce out of your equation, you can do dimensional analysis. So we will keep trying this, and we will get better at this as we go.